Hello, my dear students. So, here is question of the day, day 3. Topic is center of mass. And here I have written JEE Advanced 2026. So, bete, what do you mean by it? So, there are some questions for which we get an inside feeling that that kind of question can come in your actual JEE Advanced, right? So that's why I have written here JEE Advanced 2026. So maybe same type of model will be asked in your actual exam, right? So you can say that is my inner feeling. So go through this question, right? And try to answer. So this question I can explain you. So two small balls of mass 2m and m are released from shown position. So balls are small in size, that is given, and their location, they are saying it is at a height of 30 root 3 centimeter from the wedge. So from this height we are releasing them, right? And then they are striking. So what is their orientation, that is also given, right? So LOC line means a line joining their common normal, that is shown, which is at an angle of 30 degree, right? So like this, these two balls are released from this height 30 root 3, and we need to find out a range of motion of balls small m on inclined plane if all collisions are elastic. And here we are assuming that 2m is not interacting with m after collision, right? So that we are just assuming, right? So that we are not thinking that in which side 2m is going, right? Now pause your video here for 2 minutes and try to solve this question, okay? So you can take around 2 to 3 minutes. Okay, some calculations are also there. You can say like, okay, 3.5 minutes you can take for this question. Now let's see the solution part of it. So if v is the velocity just before colliding with wedge, then just before collision I can write v square by kinematics formula. Now visual inspection here, that is required in this question. So if you see that LOC line, right, and lower ball and wedge, means if they are coming here and if you draw normal here, so what we are getting, a common normal line for the two balls, and the lower ball and the wedge we are getting this common normal line, right? So that is our visual inspection, okay? So now the crux point. So now here what we need to see, that what will happen exactly. So first 2m will interact with the wedge, and due to its interaction it will change, means velocity of 2m will be changed, and with that new velocity acquired it will strike with m, right? So that diagram also I have shown. So that is a diagram, okay? So v velocity, so its components are v by 2 root 3 y by 2, okay? So now all the collisions are elastic, this velocity will remain same, and the along normal velocity will just get reversed. So now if I am resolving velocity of m also just before collision with 2m, that is m, so root 3v by 2 and v by 2 down, okay? So it is just like an elastic collision of ball 2m and m, and their common normal velocities are v by 2 and v by 2, right? So that I am solving first. So velocity of ball m normal to wedge after collision, so that I am finding. So by calculation, so what is that formula? So you can ignore that formula also, means by linear momentum conservation and total kinetic energy conservation also you can get that, okay? But if you can remember that formula, it's good only. So like this, v1 dash is equal to m1 minus m2 upon m1 plus m2 into v1 plus 2 m2 v2 upon m1 plus m2. For elastic collision, that is a formula, and it is for completely head on. So if it is not head on collision, then along common normal you can apply that formula, okay? And the time of flight formula, time of flight on inclined plane. So time of flight will only depend on this component, okay, 5v by 6. So this time of flight we are finding. So time of flight we are getting 10v by 3g. Now range along the inclined plane, range we are getting. So range is ut plus half at square, that formula we are applying, right? So then we are getting this is range, right? So little bit calculations are there in this question. Otherwise conceptually is not that difficult question. So only we need to visualize it properly, that what is going on, right? So what data they are giving, okay, so what we need to do first. So all small things we need to take care. So then the range are, we are doing the calculations and we are getting finally range as 8 meter. So that is our answer, okay. So anything not getting, please message me in the comment section, okay. But this question I'm feeling like very important and in trend, this question, right? So please do not ignore this question. Thank you.